Welcome friends. In this module, we are going to see the implementation of programming languages. The objectives of this module are to get an idea about the implementation of the programming languages, to study about the various procedural units such as procedures, to understand the different approaches of parameter passing, to study about the translation of high level programs, to learn about the parallel computing and declarative programming. Earlier we have discussed the history and evolution of programming languages. In order to use a programming language, we need to know the programming concepts and procedural units. In this module, a brief description of the procedural units and the implementation of languages are given. Procedural units. Dividing large programs into smaller manageable units has many advantages like easy for management, enhances readability, and these smaller units can be reused, etc. The procedure is a major technique for obtaining a modular representation of a program in an imperative language. Procedures. A procedure is a set of instructions for performing a task that can be used as an abstract tool by other program units. When the service of the procedure is required, control is transferred to it, and after the procedure is finished, control is returned to the original program unit. The process of transferring control to a procedure is often referred to as calling or invoking the procedure. The program that requests the execution of a procedure is often referred to as calling unit. A procedure is similar to a program in that procedures contain declarative statements that describe variables used in the procedure, followed by imperative statements that describe the steps to be performed when the procedure is executed. A variable declared within a procedure is generally called a local variable in the sense that it can be referenced only within that procedure. So, more than one procedure written independently can use the same variable names without any confusion. The portion of a program in which a variable can be referenced is called the scope of the variable. Hence, the scope of a local variable is the procedure in which it is declared. The variables whose scopes are not restricted to a particular part of the program are called global variables. The definition of a procedure starts with a statement known as the procedure's header, which identifies the name of the procedure. The body of the procedure specifies the statements that define the procedure's details. Modern programming languages allow the invoking or calling of procedures by simply stating the procedure's name. Parameters. Procedures are often written using generic terms. These are made specific when the procedure is applied. For example, procedure sort list describing the sorting process of the list which is passed to the procedure when it is invoked. If it is a student list, the procedure will sort the student list. If it is a list of guests, the procedure sort will sort the list of guests. However, list is a generic term which refers to different types of list. These generic terms are called parameters. More clearly, the terms used within the procedures are called formal parameters, and the precise meanings assigned to the formal parameters when the procedure is invoked are called the actual parameters. In other words, formal parameters are the representatives of the actual parameters within the function. Most programming languages require that when defining a procedure, the formal parameters be listed in parentheses in the procedure's header. Most programming languages also use parenthetical notation to identify the actual parameters when a procedure is called. The function invoking statement or the function call consists of the procedure's name followed by a list of the actual parameters enclosed in parentheses. When more than one parameter is involved, the actual parameters are associated with the formal parameters in the procedure's header entry by entry. That is, the first actual parameter is associated with the first formal parameter, the second actual parameter with the second formal parameter, and so on. The task of transferring data between actual and formal parameters is handled in a variety of ways. The commonly used mechanism for passing parameters are pass by value and pass by reference. In the pass by value method, a duplicate of the data represented by the actual parameter is produced and given to the procedure. Hence, any change to the data made by the procedure will not affect the data in the calling program. Hence, pass by value protects the data in the calling program from being mistakenly altered by a procedure. But this method is inefficient when large blocks of data are to be passed to a procedure. Then the technique used is to give the procedure direct access to the actual parameters by telling it the address of the actual parameter in the calling program. In this case, the parameters are passed by reference or passed by address. Passing parameters by reference allows the procedures to modify the data residing in the calling environment. If parameters are passed by value, the change to formal parameters in the procedure would not be reflected in the actual variable. But if parameters are passed by reference, the value of actual would be changed if the procedure changes the parameter. Functions. Function is a concept used in many programming languages which is slightly varied from the procedure. Sometimes the purpose of a procedure is to produce a value rather than perform an action. If the purpose is to produce a value, the procedure might be implemented as a function. A function is similar to a procedure except that a value is transferred back to the calling program as the value of the function. Languages like C, C++, Java, C#, etc. use functions, and the value computed and sent back to the calling program may be stored in a variable for future reference or may be used immediately. Functions are defined within a program in much the same way as procedures. The difference is that a function header usually begins by specifying the data type of the value that is to be returned, and the function definition ends with a return statement in which the value to be returned is specified. For example, int area, int L, int B. Int A equals L into B, return A. Language implementation. Here we are going to see the process of converting a program written in a high level language into a machine executable form. Since the machine can understand only zeros and ones, each and every instruction or statement written in any other form than the strings of zeros and ones need to be converted into machine understandable form before execution. This is done in different ways using special programs called translator programs. The translation process. The process of converting a program from one language to another is called translation. The program in its original form is the source program and the translated version is called the object program. The three activities associated with a translation process are lexical analysis, parsing and code generation. These are performed by the lexical analyzer, parser and the code generator. Lexical analysis is the process of recognizing which strings of symbols from the source program represent a single entity. For example, the three symbols 206 should be interpreted as a 2, a 0 and a 6, but should be recognized as representing a single numeric value. Similarly, even though a word composed of individual symbols, it should be interpreted as a single unit. Thus, lexical analyzer reads the source program symbol by symbol, identifies the groups of symbols that represent single units and classifies those units according to whether they are numeric values, words, arithmetic operators, and so on. The encoded unit by a lexical analyzer is known as a token, and these tokens are the input to the parser. The lexical analyzer skips over all comment statements. The parser views the program in terms of lexical units or tokens rather than individual symbols. The parser groups these units into statements. The parser's job or parsing is the process of identifying the grammatical structure of the program and recognizing the role of each component. To simplify the parsing process, early programming languages insisted that each program statement be positioned in a particular manner on the printed page. Such languages are known as fixed format languages. Most of the modern languages are free format languages, which imply that the positioning of statements is not critical. The free format languages allow the programmer to write the programs in a way that enhances readability from a human's point of view with indentations. To parse a program written in a free format language, the syntax of the language must be designed in such a way that the structure of a program can be identified regardless of the spacing used in the source program. Hence, most free format languages use semicolon to mark the end of the statements, keywords such as if, then, else, etc. The keywords used in a programming language are often reserved words and cannot be used by programmers for other purposes within the program. The process of parsing is based on a set of rules that define the syntax of the programming language known as grammar. One way to express these rules is by means of syntax diagrams, which are the pictorial representation of a program's grammatical structure. For example, the figure shows the syntax diagram of the if, then, else statement. The terms used that actually appear in an if, then, else statement are enclosed in ovals and are known as terminals. Terms that require further description, such as Boolean expression and statement, are enclosed in rectangles and are known as non-terminals. The manner in which a particular string conforms to a set of syntax diagrams can be represented in a pictorial form by a parse tree. The parse tree for the string x plus y star z can be expressed as given below. The tree starts at the top with the non-terminal expression and at each level shows how the non-terminals at the level are decomposed until the symbols in the string itself are obtained. The process of parsing a program is essentially the construction of the parse tree for the source program. The parse tree represents the parser's interpretation of the program's grammatical compositions. So, the grammar must not allow two distinct parse trees for one string. If a grammar allows two distinct parse trees for one string, it is said to be an ambiguous grammar. A parser analyzes the grammatical structure of a program. So, it is able to identify individual statements and to distinguish between the declarative and imperative statements. As it recognizes the declarative statements, it records the information being declared in a table called the symbol table. So, the symbol table contains the names of the variables appearing in the program along with the data types and data structure associated with those variables. When the parser analyzes the imperative statements, the meaning of operator can be determined only if it knows the data type of the variables or operands associated with it. If both the operands are of type integer, the parser will request the code generator to build a machine language instruction using the machine's integer addition opcode. If both are of type real, the parser will request to use the floating point addition opcode, etc. But when the operands are of different types, the parser has to request the code generator to build the instruction to convert one value to the other type and then perform the addition. Such an implicit conversion between different types is called coercion. But most of the modern languages are strongly typed, indicating that all activities requested by a program must involve data of agreeable types without coercion. The final activity in the translation process is code generation. In this phase, the machine language instructions to implement the statements recognized by parser are constructed. Now, the issue corresponds to producing efficient machine language versions of programs. For example, the two statements x becomes y plus z and w becomes x plus z are translated as individual statements. Each would require that data be transferred from main memory to CPU before the indicated addition takes place. But efficiency can be gained by recognizing that once the first statement has been executed, the values of x and z will be in CPU's register and need not be loaded again from main memory. Such insights implementation is called code optimization, which is an important task of code generator. However, the steps of lexical analysis, parsing and code generation are not carried out in a strict sequential order. The lexical analyzer begins by reading characters from the source program and identifying the first token. This token is handed over to the parser. The parser analyzes the grammatical structure of the token, then it might request another token from the lexical analyzer, or it calls on the code generator to produce the machine instructions if a complete parser or statement has been read. The code generator then builds the machine instructions that are added to the object program. Hence, the task of translating a program from one language to another conforms to the object-oriented paradigm in which the various objects such as lexical analyzer, parser, code generator and object program interact by sending messages back and forth as each object goes about performing its task. Software development packages. The software tools like editors and translators are used in the software development process and are often grouped into a package to function as an integrated software development system. By using this application package, a programmer gains ready access to an editor for writing programs, a translator for converting the programs into machine language, and a variety of debugging tools that allow the programmer to trace the execution of a malfunctioning program to discover the bug in it. Such an integrated system has numerous advantages. The programmer can move back and forth between the editor and debugging tools easily and can test the program if any changes are made. These packages allow related program units that are under development to be linked in a fashion that access to related units is simplified. Some packages even maintain a record of alterations. These capabilities are useful while developing large software systems. On a smaller scale, the software development packages are customized to the programming languages being used. They will provide automatic line indentation and automatically complete keywords after the programmer has typed only the first few characters. They will highlight the keywords within source program with different color that enhances readability. The software development packages based on component architecture model use graphical interfaces in which components can be represented as icons on the screen. A programmer can select the desired components with a mouse and can be customized by means of packages editor. These can be attached to other components by pointing and clicking with the mouse. Parallel computing. The simultaneous execution of multiple activations is called parallel processing or concurrent processing. True parallel processing requires multiple CPUs. When only one CPU is available, the illusion of parallel processing is obtained by allowing the activations to share the CPU time in a manner similar to that of time sharing operating systems. Parallel processing helps to solve the problems easily than in a more traditional context involving a single sequence of instructions. Modern programming languages provide syntax for expressing the semantic structures involved in parallel computations. Each programming language tends to be parallel processing paradigm in its own view with different terminologies. An activation is formally called a task in Ada and a thread in Java. Ada permits concurrent processing by multiple tasks to be performed. In Java, one has to create multiple threads to allow simultaneous processing. The difference between traditional and parallel programming paradigm is, in the traditional setting, the program unit that requests the activation of a procedure does not progress any further until the requested procedure terminates, whereas in the parallel context, the requesting program unit continues execution while the requested procedure performs its task. An issue related to parallel processing involves handling communication between threads. The various problems such as race condition, deadlock, etc. have been discussed earlier. These problems are solved with critical sections and semaphores up to some extent. These methods ensure mutual exclusion, but a mistake in a single segment can corrupt the entire system. So, a better solution is to assign the data item with the responsibility to guard against multiple access. A data item augmented with the ability to control access to itself is often called a monitor. So, the design of programming language for parallel processing involves developing ways to express such things as the creation of threads, the pausing and restarting of threads, the identification of critical regions and the composition of monitor. Declarative programming. The logic provides a general problem solving algorithm around which a declarative programming system can be constructed. Logical deduction. There are different techniques for deriving a consequence from a collection of statements called inference rules. One of these is called resolution. In its general form, the resolution principle states that from two statements of the form P or Q and R or negation Q, we can conclude that the statement P or R, where P, Q and R represent simple statements and negation indicates the negation of the statement. In this case, the two original statements resolve to form the third statement called the resolvent. The resolvent is a logical consequence of the original statements. If the original statements are true, the resolvent must also be true. In the above cases, if Q is true, then R must be true, but if Q is false, then P must be true. Thus, regardless of the truth or falseness of Q, either P or R must be true. A collection of statements is said to be inconsistent if it is impossible for all the statements to be true at the same time. The process of assigning values to variables so that resolution can be performed is called unification. Prolog. The programming language Prolog or programming in logic is a declarative programming language whose underlying problem solving algorithm is based on repeated resolution. Such languages are called logic programming languages. A program in Prolog consists of a collection of initial statements to which the underlying algorithm applies its deductive reasoning. These statements are constructed from the components known as predicates. A predicate consists of a predicate identifier followed by a list of arguments. For example, the fact that a rabbit is faster than a turtle can be expressed as faster in parenthesis turtle, rabbit. In Prolog, constant arguments start with lowercase letters and variable arguments start with uppercase letters. Statements in Prolog can be either facts or rules. These are terminated by a period. The Prolog system does not know the meaning of the predicates and simply manipulates the statements in a symbolic manner according to the resolution inference rule. When using Prolog for program development, the programmer has to develop all the facts and rules that describe the information that is known. This module describes about the implementation of a programming language for problem solving and other applications. This module starts with the procedural units such as procedures, parameters and functions. In order to use a program written in a language other than machine language requires the program to be translated into the machine code. Hence, the translation process is discussed in detail. To help the programmer with editing and debugging, some modern languages provide a package of software tools consisting of editors, translators and debugging tools, etc. This module concludes by referring to the parallel computing and declarative programming. Please try to answer the following questions. Differentiate between a global and a local variable. Compare between procedure and function. What is the difference between actual and formal parameters? Describe the various phases of translation process. Books for your reference. J. Glenn Brookshire, Computer Science An Overview, 10th edition, Addison Wesley. Peter Norton, Introduction to Computers, Tata McGraw-Hill Education Private Limited.